Howdy howdy, this is Mr. Potter. In this last video, or the last series of videos, we're going to be going through the third of the AP exams, and that's the 11s lab. The whole idea behind the 11s lab is that we're going to be implementing a card game called 11s, where we're supposed to find cards whose values add up to 11, like this 3 and this 8 here. Come on. Or, if we have a jack, a queen, and a king, we can click on those as well. And the idea is that, I keep playing as long as I can come up with a pair that add up to 11, and as soon as I no longer can, because there's only 9 places here, then the game is over. So here's a jack, and a queen, and a king. So let's click, come on, jack. And so what we're going to do is we're going to talk about implementing this pretty much from the ground up. So the first thing we're going to do is we're going to talk about what actually constitutes a card and what actually constitutes a deck. So let me go ahead and finish this up real quick. This game is pretty difficult. I mean, basically you end up with about a 20% chance of winning whenever you play. Here, notice I've got 25 undealt cards left and I've lost, and it gleefully keeps track of how many wins and losses you have. But we're going to be talking about how to develop this, but I really want to start this from the basis of a card. The question is, what is a card? And if we're talking about a standard card, we know that cards have a soot and cards have a rank. So when I talk about the rank of the card, I'm talking about ace, 2, 3, 4, and whatchamacallit, up through jack, queen, and king. The soots that we normally have, our traditional soots, are hearts, spades, clovers, and or clubs, and diamonds. But then cards also have a point value that goes completely different to the idea of the rank. For example, when I'm playing blackjack, an ace could be worth 1 point or an ace could be worth 11 points. So the rank of the card does not necessarily correlate to the point value of the card. Similarly, in some games like spades, you have that a king is distinctly higher from a queen, which is distinctly higher from a jack, which is distinctly higher from a 10. So your ranks may be 10 for the 10, 11 for the jack, 12 for the queen, 13 for the king, and 14 for the ace, because you want your ace to be your dominant soot. And of course, your dominant rank. And there are some games where the 2 ends up being higher than the ace. So the fact that a card has a rank to it, that doesn't necessarily tell you what the point value is. So those are 2 distinct things. The other aspect is when I'm talking about a rank, I can use letters in ranks. So, for example, I've got the A of an ace, or I've got the Q for a queen. So I really want to use like a char or a string in here. And in our example, we're going to be using strings. But a point value needs to be something numerical that we can actually directly compare. I don't want to have to go through the rigmarole of trying to get a compare to work. It's much easier just to slap a less than or greater than when I need to. So we're going to talk about how to develop a card. So keep in mind that when I'm talking about a card, I'm going to have a card rank, a card soot, and a card point value. These are all instance variables that we're going to need to assign. So we'll go ahead and talk about how to assign those. This is my overloaded constructor, so all I'm going to be doing in this part is just implementing these values. So I'm going to say that my soot gets my card soot, and my rank gets my card rank, and my point value gets my card point value. So just very straightforward, just assigning my instance variables to the parameters of the constructor. And I also am going to have accessors for these variables. So I've got a suit accessor. So we're just going to return soot. And we have a rank accessor. So we're going to go ahead and return rank. And by the way, you see this slash star and this star. These are a special type of comments that are used with Java docs, which is a special code that you can run on programs to create documentation for your programs. You'll see quite a bit of this here. We'll notice the return parameter tells me that this is telling me that it's going to return what it's going to do. It's nice to have in the comments, but when I run javadoc as an executable file on this, it's actually going to create an HTML file that have links that tell me this is what it returns, this is what the parameters are, and so forth. So I'm returning my soot, returning my rank, and returning my point value. So I've got these three accessors set up because of encapsulation, because I really want to keep all of my private data private. I want it to be accessed, but to be accessed my way, using the proper accessors, or to be changed using the proper modifiers, or the constructor. So now I've got this other method called matches, and I'm specifically not using the dot equals method because the dot equals method has a lot of overhead that goes with it. The whole idea here is I just want to make sure that whatever card I have matches whatever card is being passed as a parameter. So what I want to do is I want to return if everything matches. So if this dot point value is equal to other card dot point value, and I have to use the method because for the other card it is a private variable. I have to use the accessor, and I want to make sure that this dot rank, I need to make sure that it is equal to other card dot rank, but because it's a string I have to use dot equals other card dot rank, and I have to use the accessor for it. And I want to return this dot, I have the point value, I have the rank, so I also want to check the suit dot equals other card dot suit. So I basically got a really long statement here, but all I'm doing is I'm checking, do the point values of the other card and my card match? Do the ranks of the other card and my card match? Do the soots of the other card and my card match? So the final thing that I've got here is my TwoString, and I actually want to have my TwoString do something very specific, and we'll talk a little bit more about this when we get into our deck class. But what this is going to do is basically converting it to something that looks nice. Remember when we talked about objects before, we noticed that the TwoString essentially returns a memory location. It's actually the hash value of the memory location, as well as the class name. So what I want to do here is I want to make sure that I'm actually implementing something that's indicative of a description of the card. So I actually want to say rank of soot. So I want it to say ace of spades, or I want it to say the 3 of coins, or whatever soots we happen to be using, and then also telling me what the point value of that particular card is. So we're going to go ahead and override the TwoString class. So we're going to return, and I need to return the rank, and then the word of, and then the soot, plus a space, and then in parentheses point value equals, and then I want to return the point value. And even though point value is an int, because of concatenation we're being promoted to a string. So I highly suggest that you take a look at the comments here, because they actually go into a little bit more detail of what I'm doing here and why I'm doing it. But this is essentially what we've been doing with classes throughout the course. Anytime that we have private variables, we need to make sure that we have accessors, modifiers for them. We need to make sure that our constructor can accommodate those instance variables, basically assigning the parameters to the instance variable. And we override the TwoString so that this is a meaningful TwoString. It's not just going to give us the hash value or the memory location or the class name, but it actually gives us some information about the object itself. So I'm going to do a real quick compile, just make sure I haven't done anything really difficult, and I think we've got everything good. So that's my card class. Now what I want to do is I want to go through the deck class, because what a deck is a deck is a collection of cards. Keep in mind that if I'm playing Uno, I'm going to have 108 different cards. I'm going to have 0 through 9 in each of the 4 colors, plus I'm going to have the skips and the draw twos and the reverse, and then I'm going to have wild cards, which really are different from those suits. And we can talk about what the rank of each of those is going to be, but we're essentially talking about a collection of cards. And I could make this an array, but I really want this to be easily accessed through methods. And we've been talking about array lists for the past few units. So we're going to have an array list, basically a list type of cards. So we're going to have cards, which is our collection of cards, and we're going to have the size, which is how many cards are in our deck. So if I'm playing a game of euchre, I'm going to have a different card size than if I'm playing with a game of spades, or if I'm playing a game of Uno, or if I'm playing a game of Skippo, or if I'm playing a game of 5000, or if I'm playing any of those card games. They're all going to have a different number of cards. They're all going to have different ranks. They're all going to have different point values that we'll have to keep track of. Keep in mind that when I create a deck, I'm actually going to have an array of ranks, an array of suits, an array of values. And so, for example, let me go ahead and bring this in as an example. My ranks would be some type of array like ace, 2, 3, and so forth until I get to my 10. And this is another reason why I'd want to have strings, because my rank may have 2 symbols in it, and then a jack, and then a queen, and then a king. And I may have my suits be hearts, spades, clubs, and diamonds. And I may have my values be, for this game, because an ace really counts as a 1, it's going to match up with a 10 to make sure they add up to 11. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to have values for jack, queen, and king, and they're probably going to be 11, 10, 11, 12, 13. Just for consistency's sake. But if I was playing blackjack, a jack, a queen, and a king, they all count exactly the same as a 10, so their point values would be 10, 10, 10, 10 for the end of this sequence. These are the parameters that I'm going to be passed. Keep in mind that my values and my ranks really do have to match up 1 for 1. They have to be the same size. My suits don't have to. But another thing to keep in mind is that I'm going to have this many cards in the heart suit. I'm going to have this many cards in the spade suit, and so forth. So the size of my array, the size of this array list that I'm going to be dealing with, is going to be the ranks dot size times suits dot size, or actually dot length, because these are arrays. So what I want to do is I want to add these cards to the list. So I'm going to go ahead and do a for each loop. So I'm going to say for string rank in ranks, and for string, actually I don't want to do that. The reason I don't want to do that is because if I use a for each loop for the rank, then I'm going to end up with an issue of how do I make sure I get the corresponding value. It's okay for me to do this for my suits, so I can say suit in suits. But what I'll want is I'll want some type of int rank gets 0, rank is less than ranks dot length rank plus plus. And then what I want to do is create a new card. So I'm going to say something like card C gets new card. And remember that we had a set of parameters for our card. Our card class had the card rank, the card suit, and the card point value. The rank comes first, so this is going to be ranks sub rank, because that's my rank position in the ranks array. The suit is just going to be soot. And the value is going to be values for the corresponding rank. So this is going to create a card object that has the appropriate rank, the appropriate soot, and the appropriate value. Notice that the rank and the value have to be comparable. It's got to be the same position in the corresponding arrays. And then once I've got that card, then I want to go ahead and add that card to the list of cards. So this would be cards.add, and I want to add C. There's a problem here, and the problem is that I don't actually have a list. I've got a variable called cards, but it hasn't been initialized. So I actually need to initialize that, and that really should be my first step. I need to say something like cards gets new array list of type card. And that way I can add card objects to this array list. Of course, if I'm going to do that, I need to make sure that array list is imported, and we're good to go for that. So I've got this nested loop that makes sure I've got all of the cards ranks in all of the soots. So if I have 13 cards in 4 soots, that should be 52 cards in my deck. Should be good to go with that. I'm going to have a variable here called size, because what I'm going to be doing is keeping track of how many cards have been used. So I also need to initialize that value. And at the beginning, no cards have been used. So I really want to set size equal to 0. And what will happen is every time I draw a card, I'll actually increment this size variable, so size plus plus, and then I'll return the card at that position. I probably want to reverse those steps. So I'll actually return the card at that position and then size plus plus. And I know if my deck is empty because one of two things will happen. Either cards will be empty, so return cards.isEmpty, empty, or if the size variable is equal to cards.size minus 1. Keep in mind that if I have 52 cards in my deck, when I hit the 51st card, I've actually gone through all 52 cards in the deck if size is equal to 51. So I'm going to have an empty deck at this point. I've got a size method. This is going to tell me how many undealt cards are in the deck. Keep in mind that my size variable is really just keeping track of how many cards have been dealt. So if I want to know how many haven't been dealt, then what I want to do is I want to return cards.size minus size. So that should tell me the size of my deck minus how many cards I've used out of this deck. Now we've got this shuffle method, and we're actually going to implement the shuffle method later. There's several ways that we can do this, and we'll need to figure out what a more efficient way is to do it, or one that actually does shuffle it, because it's really easy to go through and not have a complete shuffling of the deck. But now I want to talk about how I deal from the deck. The idea of dealing from the deck is that I should be able to get a card and then make sure that that card's not going to be picked up again. So what I'm going to do is I'm going to get the card first. So card C gets, and I'm going to get cards.get for whatever size is. I want to make sure I size plus plus, and then I want to return C. So I draw the card. I make sure that that card is now part of the drawn part of my list. So size plus plus. So I'm not going to draw that card again. And then I go ahead and return the card that I've drawn. And then finally we need to do the TwoString here. It looks like it's already done for us. So let's see. So our string return, the return string, is going to say the size equals the size, and this is how many undealt cards we have. So apparently we're using size as the number of undealt cards. We'll probably need to tweak that. So let's go ahead and go back up here. And if I'm doing that, if size is equal to, this would actually need to be cards.size. And what I'll need to do is just return cards.size. And then I need to make sure that when I get at that card, I actually want to size minus minus. So that way, if size is equal to 0, we're going to have an empty deck. So I had to make this tweak just because looking at this TwoString, I get a better idea of what the author's looking for us to do here. I had thought that if I had the barrier between the undealt cards and the dealt cards starting at the beginning of the list and slowly moving towards the end of the list, that would work. Certainly I can do the same thing and just have it go to from the end of the list back to the beginning of the list. That would work as well. Both work fine. They're both good implementations of it. I'm just trying to be consistent with the original author is doing here. So we've got size, gets, and size, and then undealt cards. So size is keeping track of how many undealt cards we have. And for k gets size minus 1, k greater than 0, k minus minus, we're going to get the cards.k. Now keep in mind when I do return gets return plus cards.getk, this is going to add the TwoString to the return. And if k is not equal to 0, then we're going to go ahead and do a comma. And if size minus k mod 2 is equal to 0, this is going to return a carriage return. That way I'm going to have 2 cards on each line. The whole idea is that as I go through this calculation, I'm going to print the first card, print the second card, and then the new line. First card, second card, and new line. So that's what we're doing with this step here, this if size minus k mod 2. And then I need to go through all the dealt cards, and I'm going to be starting at the end and going to my size thing. These are all the cards that we've dealt in the order. And we're doing the same idea here, the same returning a carriage return after printing 2 cards. So let's compile this, see how this works. And then we want to go to this deck tester. So we need to actually create a deck of cards. So first thing I'm going to do is create a string array called ranks. And we're going to set up ranks. So I'm going to have an ace, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, and a king. And that's going to be my array of soots. And then we're going to need to create a array of, that's my array of ranks. Now I need an array of soot. So string array soot gets, and my soots are equal sign. My soots are going to be spades, hearts, clubs, and diamonds. Close brace and semicolon. And then we're going to create an int array called our values, which is going to have the values of our cards, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're saying our jack, our queen, and our king are going to have different values. So this sets up the parameters so that we can create a deck. So a deck D gets new deck, and our constructor for deck actually has 3 things here. It has ranks, soots, and values. So I'm going to pass ranks, soots, and values. And this creates a deck, and now what I want to do is I want to system.out.println D. So this is going to call upon the TwoString method of the deck, so it should print all of the cards that are here. Then I'm going to system.out.println d.deal, because I want to deal a few cards out. Stop that. Okay. So I want to go ahead and deal a few cards out of here. So we've got d.deal, 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 and then I want to system.out.println d again. So I want to see if after we've dealt 3 cards, do we actually have our deck thing moving appropriately. So we're going to go ahead and compile this. Hopefully that works, and we're going to run this, and I believe I'm capturing all my output down here. So a lot of stuff's being done, and I got an error, which we need to take care of real quick. So here's my original deck, size 52, undealt cards. I've got the King of Diamonds, Queen of Diamonds, Jack of Diamonds, 10 of Diamonds, 9 of Diamonds, 8 of Diamonds, 7 of Diamonds, 6 of Diamonds, 5 of Diamonds, 4 of Diamonds, and so forth. No dealt cards, but we ran into a problem when we tried to deal our first card. Dealing a first card actually ran into an issue because we looked at get at position 52. So we're going to take a look at our deal method and make sure that we're implementing it. And this may have been a change that we didn't do correctly. Yeah, size. Remember, we originally set size to be whatever cards.size is. So I actually want to kind of trade these two statements here. I want to make sure that I size minus minus first, and then card C gets cards.get size, and then return it. So we'll go ahead and compile this just to make sure it works good, and then we'll go ahead and run this. And maybe this will work a little bit better, and it certainly looks like it's working a little better. So let's see. So here's our original deck, our pristine deck. I probably should have closed parentheses on my TwoString method. That'll be something I'll fix in just a moment. And I have nothing dealt at the very beginning, but then I deal off these cards here. Remember the first three cards of my deck, which happen to be the King of Diamonds, Queen of Diamonds, and Jack of Diamonds. And then I take a look. The next card that's going to be dealt is the 10 of Diamonds, because that's the order that we did our adding to this array list. And it tells us the three dealt cards that we had, the King of Diamonds, Queen of Diamonds, and Jack of Diamonds. So I'm going to go back real quick, just fix that TwoString method, and that TwoString method is actually in the card class. It's not in the deck class, because my my drawn cards actually had that issue as well here. This King of Diamonds, Queen of Diamonds, Jack of Diamonds. So in my card class, I need to make sure that I've got the final close parentheses here, and we should be good to go. So what we've got now is we have two classes, a card class, which represents a card object in a card game, and we have a deck class, which represents a collection of them that we can get values out of. You'll notice, of course, that the objects were actually put in ace through king, so ace comes first, then king, then ace comes first, then king, ace comes first through king, ace comes first through king. And it's in the order that we put our soots in our array. So our array originally had spades, followed by hearts, followed by clubs, followed by diamonds. See that we've got spades in our deck first, then hearts in our deck, then clubs in our deck, then diamonds. And of course, I could format these a little bit nicer. I could actually use, there are certain escape characters or certain control codes that I can use, maybe Unicode values to actually get a physical spade to show up or a physical heart to show up. That would be something I could do to prettify this up. But this basically gets the mechanics of the objects that we're going to be dealing with. Everything else beyond this is really dealing with the logic, not only the logic of how do we physically shuffle a deck of cards, but what's the logic behind the game as well. And that's something we're going to be talking about in future videos. So once again, this is Mr. Potter. Thank you for watching. Have a great day.